All right, Mihai, take it away with, you can open up for questions first or continue talking, your choice.
Yeah, I think I'm presenting the wrong screen. Am I? I have to switch this. Let's see how I do that. So what are you seeing?
I see a PowerPoint slide in the kind of the upper right 3/4 or 2/3 of the screen.
Nah, yeah. So I'll start first the presentation and then the screen sharing. I'll share the right screen. How is this?
That looks like full screen. I don't even see your PowerPoint menus anymore.
Okay. Well, so what we're doing here is last 2 weeks ago, I gave this talk on the structure of the compiler, and is there a place where you shared the presentation?
I did. I sent out a link to the P4Dev email list, which I do for all meetings with notes. And my plan is to get it on the youtube.org, YouTube P4.org channel eventually, but it's not there yet.
Okay, so just to remind you, so the talk is about the structure of the open source compiler. And this is how it looks. And in the talk, we discussed several things. We discussed essentially the architecture of the compiler, how the programs are represented using a so-called intermediate representation. And we discussed about the visitors. The visitors are the code that crawls over the intermediate representation and modifies it. And we only had 3 slides left at the end. So we talked how visitors take. So I'll remind you that the intermediate representation is actually an immutable DAG. And visitors, so this is an example. So a rooted DAG, a DAG with a single root. So, and the visitor is a function essentially that you apply to this DAG to produce a new DAG. They are shown as triangles here, the DAGs. DAGs stands for directed acyclic graph. And essentially the compiler is just a long succession of hundreds of passes that are applied to produce new DAGs from the existing DAGs. And this is a snippet from the real front end that you can read. It's on the open source repository. See, this pass manager is just a collection of passes that will be applied in sequence. So you create this pass manager visitor, which has get one v1 model version visitor, a parse annotation bodies visitor, a pretty print visitor, and so on. There's many of them, and then you say take the program and apply all these passes in sequence to the program, and this returns a new program. This is how the compiler works. And I'll remind you this important picture, which says that all visitors produce new DAGs. The old DAGs are left unchanged and new ones are created. In general, when you write a visitor, you just describe how you modify a subtree of the DAG, a rooted subtree. You do some kind of pattern matching and say, for example, whenever I see an addition operation, I want to rewrite it as in some other way. Maybe, let's say addition of a plus a becomes multiplication with a with 2. And so you replace an original DAG with a new DAG, and then the visitors will apply this wherever you find a node in this big program DAG that matches. The visitor will apply the transformation and create a new DAG for you, where the blue tree has been substituted with a green tree. And the visitors will automatically construct a new spine. So see, this blue tree was reached through a sequence of orange nodes from the root. This sequence of orange nodes remains unchanged, but you get a new tree where the orange nodes are replaced with some yellow nodes. This is a technique called copy and write. So you have now both the original DAG if you start from the original orange root, and the new DAG if you start from the yellow root. And where we were in the discussion is how do you do several things. So I showed you how you can replace a node, but how do you delete a node? Well, you can delete a node in multiple ways. One solution is actually to visit the parent of that node, and the parent will have a set of children, and essentially just not insert that node in the list of children. And this is how you achieve a deletion. But sometimes it's tricky to look at the parent node. Often you can look at a node and say, I don't want this node anymore. And then the solution is in the visitor class that in the visitor method that processes this particular node, just return a null pointer. And this will cause the node to be deleted from the parent. If the parent can legally have a collection of children. In some places, for example, let's say you have an add operator which adds 2 values, it's illegal to have any of the operands of the add be a null pointer. You can't just delete an operand of an add and get a legal program. But if you have a sequence of declarations, then usually it's okay to delete a declaration because the result is still a sequence of declarations, possibly empty. So this is an example which will delete a table. So let's say we had a pass which checked with whether a specific table is being used. And here we have a method which says if the table is not used, just we want to delete it. So essentially we return a null pointer, and this will cause the table to disappear from the original program. And this prune call here, essentially, if you remember, the pre-order method is called before you visit the children of a node in the tree or in the DAG. And prune says, oh, don't bother visiting the children. Since we are going to delete this node, we don't care about the children anymore anyway. In this case, that's why we don't want to visit them. All right, so this is how you delete a node. And then I showed you previously how to modify a node. And the third thing you might want to do is insert a node. So for example, you want to insert a new variable declaration in your program because you factored out some expression and you want to assign the result to a temporary variable. So you want to create a new declaration for the variable. And the way you do that is instead of returning an object of the same type. So for example, when you process a control, you expect to return a control, you can actually return a vector. And in this example, I'm inserting a new node next to the existing one. So for example, I have a method which says what should be inserted. This find insertions method, I'm not showing you the body of it, will return you all the objects that have to be inserted prior to this particular control. So I have a control, I did some analysis, and I want to create some new global declarations. So now the way to insert those declarations before the control is to create a vector, insert the control, and then add all the declarations that we want to insert. Actually, the way this code is written, they will be inserted after the control. But if you swap the pushback of the control with the for loop, you will get them before the control. And returning a vector will actually cause all these objects to be inserted before or after the current object. But if you don't insert the current object, they will replace the current object. But this is only legal if the parent of the current node is a vector itself. Otherwise, you can't return a vector. So again, for example, if you have your parent is an add operation, you can't have 2 right side operands for the add. You can't just return a vector for that. So this is not legal everywhere. But usually wherever you have declarations, you can have an unbounded number of declarations. And the last technical slide was, okay, so all the transformations I've shown so far will convert P4 program into another P4 program using the same intermediate representation. But when you write a backend, you need to generate something new. You don't need to generate P4 anymore. So there's actually quite a few examples in the repository. There's 6 backends in the repository that you can see, and each of them generates a different kind of code. Here I showed an example that could be part of the, for example, BMV2 backend. The BMV2 backend generates a JSON file, which is then fed to the BMV2 simulator, and essentially the simulator will interpret this file at the runtime. And to generate something new, one way to do it is, for example, to keep a map in which you map each node in your tree, which is an IR node, to some other object that you want to generate. In this case, it will be a JSON object. And then what your functions will do, you will have a visitor that doesn't return anything new. It's like an inspector. It's a visitor that only crawls the IR tree, but as a side effect, it populates this map And from this map, you will be able to read and maybe or either partial results or maybe the whole result that you can then dump to the output, depending on what your target is. So let's look at this code, which compiles a binary operation. How do we do generate JSON for binary operation? All right. The representation of the binary operation in this case is a JSON object. This is we have a little library to generate JSON. Essentially, JSON object creates a JSON object, which if is the thing is between curly braces in JSON. If you look at the JSON grammar, and what we do, we actually will set 3 fields for this object. A field called op, and the op field will actually have the name of the binary operation. See expression get op string. This is a field of the binary operation that returns a string. And then what we will do, we have probably, this is the post order function. So we have crawled the left and the right children of the binary operation. So now we look in the map to get the left child and the right child. They are just JSON objects, and we stick them in this object as L is the JSON object, and we stick it in the object with the left label. And the right object, we stick it in the object with the right label. And then we in place, in the map, we set the object corresponding to the expression to be this new object that we have built, E. So this is a typical pattern that you could use. But you can really build any data structure you want by crawling the visitor tree, the IR tree. And I think this slide I've showed last time. The point is that P4 is a relatively simple language. You know, it has no memory allocation. It has no loops, if you don't count parser loops. It has relatively few libraries, and it's very limited in what it can do. It has no hash tables. It has no lists. It has no dynamic memory allocation. It doesn't even have floating point. So the compiler itself is relatively simple because of that. Many complicated analyses that would be required for a full-blown language don't need to be done for P4 programs. And I think contributing to the P4 compiler is not difficult. There is some learning curve, but it's much simpler than writing contributions, for example, to LLVM or GCC. So I think if this is what you need to do in your job or in your hobby, as a hobby, I think you shouldn't be afraid of trying it. And we designed the compiler to be modular and extensible. At least the front end, you know, some backends are proprietary, so we don't know how they look. But everything that is in GitHub is designed to be extensible and easy to understand. It's not designed for performance. We could argue that the compiler is too slow and bulky, but we optimized for making it easy to modify and test and extend. So the 6 backends you read the code, you can read the code of in the public repository. And the IR is not, it looks complicated, but it's fairly close to P4. So if you understand P4, you will understand the IR. And the philosophy is like Unix. Unix pipes are composed of little programs that each of which does only one thing simply, and it does it well. So the same philosophy is employed in the P4 compiler. Each pass does one thing, either one analysis or one transformation. And we chain lots of such analysis and transformations to do the end-to-end conversion. And essentially, the front end tries to give a simple program to the backend. So many things that are complicated in P4, like generic types, they completely disappear by the time you reach the backend. You don't have to worry about them. So you actually deal with a relatively simple language. And I've reached the end again.
Great, thanks. And well, I guess now if anyone has any questions, please go ahead. I was planning to use the rest of the time today for either questions from Mihai or shooting the breeze if we run out of questions.
You already had a different presentation scheduled. Do you know when that will happen?
I'll wait it's Tomasz Asinski. I'll wait until he says he's recovered and ready to go. I'll certainly announce it when he reschedules that.
So the next meeting is scheduled for 2 weeks from now, right? That's most likely.
We do already have volunteer Radostin presenting again on, I've forgotten the topic right now. I've got it written down, but I'll look it up.
Okay, so Radostin is in 2 weeks, so that will happen maybe in 1 month.
Correct. hopefully.
I think Thomas said that his talk is about half an hour, so perhaps we can. My talk will also be short, so we can both present next time, I think.
Sure, I'll ask him if he's ready.
Thanks.
But you know, it's not good to rush stuff. This is so if one of you will take longer, it's better to answer questions rather than try to pack as much content as possible. The main point of this meeting is communication and data information exchange between all parties.
Thanks.
Anyone got any questions they want to ask Mihai in public? That's just a joke.
Hi, Mihai. I'll ask you a question to show how ignorant I am. If I wanted to do a front end to walk the IR tree, or I should say a back end, and walk the IR tree to do something with just the packet structures embodied in the parser trees, what would be a good starting point in the existing backends to learn from and, let's say, extract practices from that?
So maybe you can build more concrete. So what you want to do, some high level analysis of the architecture structure?
I'll be more concrete. So Keysight has created a open traffic generator data model that's on GitHub that it can be used for describing interfaces to packet testers. And I have a pet project I'd love to do someday where we parse a P4 program and generate templates of these packets that can be then used in packet generators all the way from software to line rate. And I'd like to know where to start in terms of pointing somebody or even pointing myself to look at a back end and say, okay, I can figure out how to extract the packet structures from the IR and then generate something out of that.
I see. I think I understand what you're saying.
An analogous project would be make a Wireshark template out of a P4 program, right? That would be something kind of analogous, but not the same.
Yeah, I guess for that you have to analyze a parser. The parser tells you how the things are stuck together.
Yeah.
Well, so if you start from a well-known model like the V1 model, then things are much easier, because in V1 model, we know that the packet structure will be represented as an output from the parser. It's the second argument of a parser has a packet in and a metadata and the packet, right?
Mm-hmm.
So you know that's where you have to look. That will tell you all the possible fields that you'll have in your packet. It won't tell you the order they show up on the wire necessarily, but you will have a list of all possible fields, and then you would have to essentially crawl the IR of the parser and do a little interpreter of the states. So in each state, you would have to look at the extract calls and see what fields of the header they populate.
I see. Okay, thanks.
But you know, if you look, for example, all the code generators have to do something similar. So the eBPF code generator generates C code out of that, and that would be a good. That's a very small piece of code, I think.
Great. That's what I was looking for, as a hint, to get to something I can work with it. I don't want to have to dissect the largest back end, find what I'm looking for.
And I'll be very happy if you have specific questions to help you get started.
Thanks.
And especially if you said, since you said your some of your spec is open source, we could do the conversation maybe in that repository.
Yeah. Okay. Thanks.
Anyone else?
I have a question. How this is from I think all
Your audio is very distorted. Is there any way you can maybe change something?
Is it better now?
No.
No.
if you want to ask it, if it's your question is short enough, maybe put it in chat and we can read it off there, perhaps.
Oh, I should give me a minute. Is it okay now, the audio?
Oh, that's much better.
Yeah, thank you. So actually, I have a question on BMV2. So I was actually using clone 3 earlier. Like, suppose if I switch it to the different clone API, like clone preserving field list. I think with the clone 3, we were actually passing the parameters which needs to be preserved, like a set of values. Like, let's say I wanna pass like a standard metadata and then few fields in the use local metadata. I used to put it in a set of values. Now it's been changed. Like, I need to give mark them as a field list, and then I used to use the field list in the clone preserve field list. But if I want to pass the entire standard metadata, how can I do that?
I can take
Okay.
this one if you want, unless you've got it, Mihai.
So first of all, let me explain why we did that. The compiler was actually broken. It wasn't guaranteed to do what you wanted when you called clone 3. And in fact, that kind of operation wasn't even expressible in P416. Now, the way it's done, it should always work, but it is more inconvenient for you. Now, with regards to standard metadata, in general, the target doesn't promise that you can copy standard metadata. Standard metadata reflects where the packet was received from. So with a new API, it's actually impossible to preserve standard metadata when you clone a packet. You can only preserve fields of the user metadata. So if you want to actually preserve standard metadata, what you will have to do is you have to copy the fields into the user metadata and then write them back to the standard metadata, either in your parser or in your ingress pipeline.
Oh, okay. We need to preserve them. We actually need to copy them to the local metadata, and then we can preserve that.
Well, we call it user metadata is the structure that you put the annotations on.
Yes. Yeah.
And the reason is that it was never clearly specified when you get a packet which fields of standard metadata you could clone and which we couldn't. Some of them you obviously can't clone. You can't lie about the port the packet is coming from. It's coming from a different port, maybe, if it's cloned. So right now, we are assuming that none of the fields can be cloned, preserved from the standard metadata. We assume that the hardware populates those and you don't have a choice. You can't override them with fields that you had previously.
Okay. So if I understand correctly, the solution for the workaround for this is to define a fields in the local metadata and then copy them and then to the local metadata and then use them and clone them, right?
Yeah. So if you want to overwrite the standard metadata, then you will copy them from the local to the standard explicitly by hand.
Okay. So no, I don't want to override the standard metadata fields, but I want to preserve some of the fields in that. So the simply earlier, like what I was doing is I was actually preserving the whole standard metadata. So I used to get the entire data structure, but now it looks like it's not possible.
Yeah, you can copy all of these fields and also tag them as being preserved, and then they will be preserved. They will just show up in this new structure instead of in the standard metadata. Andy, is this the answer you wanted to give as well?
Yep, that's the workaround I would recommend.
Okay, so like defining a new like a structure in the local metadata and then copy them from standard metadata to the local metadata before cloning, and then we should be able to preserve them after clone, I believe, right?
I think it doesn't even matter. You can copy them after cloning. Essentially, the value of these fields at the end of the pipeline will be preserved.
Okay,
But yeah, add new fields to local metadata. Whether they're in a substruct or top level fields in your structure is your choice.
One thing I haven't tested is whether you can have a whole field which is a struct and just put one annotation on that one. I don't know if we have tests for that. That might just work. So then you don't need to tag all the fields.
Yeah. Okay. So and because it's suppose if I'm copying at one place in my ingress pipeline, I mean it is gonna preserve that value, right? So it's not, suppose if I change something later because I haven't copied to the local metadata, it is still gonna be preserved what I have copied, right? Am I right?
It's actually a little bit more subtle than that. When you annotate a field with this new fieldless annotation, what gets preserved is the final value it has at the end of your ingress or the end of your egress, wherever you're doing the clone operation. It won't be the one at the time of the assignment, the first assignment.
Oh, okay.
You will actually wait and do the copying at the end of the ingress or egress pipe where the clone was requested.
Okay.
Yeah, so let's say a field is 1, you call clone, and then you set the field to 2. Actually, 2 will be preserved, not 1.
Okay, got it.
Is the last value when the pipeline terminates.
Sure. Okay, all right. Yeah, I got the answer. Thank you.
All right, we're a little bit past time here. I need to go to another meeting, but thanks everybody for joining, and see you next time.
Thank you.
Thank you.